Okay, welcome. Today we're going to be doing an activity series to see how different elements react in water. In this case, we have sodium metal, as you can see on the label. It says flammable solid. And we're going to take a look and see what that looks like. Now I'm wearing gloves because you don't want to touch sodium with your bare hands because the oil's in your hand. And it's actually a mineral oil. If you look in the jar there, that's mineral oil that actually contains the sodium, which is nonpolar, so it's not going to react. It doesn't have any electrons to give up. So that's sodium. It's a metal. Not like the metal that makes up these forceps, but it's a really soft metal. And as you can see, you can actually take it and cut it. That's how soft it is. It's a soft metal. Okay? So sodium's configuration has a S1, right? It's got one valence electron. And we're going to see how this reacts in water. So here's some water here. And I'm just going to take a small sliver of this. We can probably do more than one of these. And I've got a beaker with tap water here and a watch glass. And what we're going to do is we're going to put this sodium inside water. See what happens here. As you can see, it's giving off hydrogen gas, and it's also releasing its valence electron. Highly unstable. Yeah, that's cool. Okay. Let me use that second piece.
No, that's okay.
Alright, so we're going to let that finish reacting. Okay, so what I have here, this is an indicator. This is phenolphthalein, and this indicates the presence of an acid or a base. So in acidic solutions, this is normally clear in color, and for basic, it's a fuchsia pink color. So we're going to see what sodium has now done. As you can see, it's gone. Right, there's the remnants of the gas, and let's see what we have in here. So if it's clear, it's acid. If it's pink fuchsia, it's a base. Let's see what we have going on here. And there you go. So we definitely know we released some sort of basic compound in here. We're going to find out what that is. All right, so that pH has increased above 7. All right, so what we're going to do, we're going to go to the whiteboard here, and just to take a look at this, my glasses here, lens are back. All right. Right. So let's look at the appearance in the activity series. Sodium. We looked at it. Its appearance, it was a dull, I would say grayish, soft metal. Right. You saw me chop it with that forceps. Its action in water, well, it was reactive. It created that smoky appearance in that mist, which was hydrogen gas. Okay. In the action of the product of the indicator, we have to ask ourselves, what color did phenolphthalein turn into? And in this case, we saw a pink fuchsia color. I can't spell fuchsia, so I'm not going to write it. All right, so a pink fuchsia color. And we know that sodium is in group 1, and it's an alkali metal, which actually gets its name from the fact that it can make a basic solution, and we saw that's what phenolphthalein did.